Okay, let's just dive right into this. For a solo developer, using basic Git is a total breeze. You commit, you push, you pull, and boom, you're done. But managing enterprise scale DevOps, yeah, that is an entirely different beast. When you're suddenly dealing with hundreds of developers, millions of lines of code, and just massive binary files, your basic version control setup is going to buckle under the pressure. Seriously, it'll just break. So today, we're going to tame that beast in this explainer. We're pulling directly from the Ultimate Enterprise Playbook to show you exactly how to manage, scale, and secure massive repositories without, completely losing your mind. Here is the roadmap for our playbook today. Number 1, architecture and managing scale. 2, security and repository permissions. 3, automating releases and documentation. And finally, 4, data cleanup and recovery. So let's kick things off with Section 1, architecture and managing scale. The very first big choice you have to make for a large team really comes down to this architectural divide, monorepos versus multiple repositories. Now, with multiple repositories, each subteam gets incredible workflow independence. They can use whatever tools work best for them, but the downside, cross-dependencies quickly turn into a total nightmare. If you find a bug in another team's library, you have to wait for them to fix it, publish a new version, and then update your code. Honestly, it's like relying on a third-party vendor. A monorepo, on the other hand, just puts all your source code in one place. Fixing a bug in a shared library is as easy as fixing your own code, simply because anyone can change anything they need to. It dramatically simplifies all those complex dependencies. But putting everything in one single place introduces a massive new challenge: size. Just think about this number for a second. Microsoft literally migrated a repository containing over 300 gigabytes of data into Git. 300 gigabytes! When repositories grow this large, and that usually happens because of a long history of commits spanning years or super heavy binary files like images and videos, they can absolutely crush local performance. Standard Git commands just weren't built to seamlessly handle hundreds of gigabytes of data on a single developer's local machine. So what do? Well, you bring in specialized tools that are actually designed for scale. First up, you have shallow clones. These basically truncate the repository's history, so you only download exactly what you need right now, which saves an immense amount of local storage. Then there's VFS for Git. That works behind the scenes to download files on demand from the server only as you actually access them. And finally, there's Scalar. This is actually a hero solution that Microsoft uses for massive projects like Windows and Office. Scalar basically accelerates performance through partial clones, a feature called sparse checkout, which physically shrinks your working directory, and a background prefetch that downloads data every hour. That way, your developers aren't just sitting there staring at a screen waiting forever to fetch data. All right, moving right along to Section 2, security and repository permissions. So in this second phase, we're shifting from how the code is stored to a much more critical question: who is actually allowed to touch it? Finding that perfect balance between seamless team collaboration and strict security is absolutely essential. And you achieve this by strictly mapping out built-in GitHub roles. Because let's face it, you don't want to give everyone the keys to the castle. You want to use the read role specifically for non-code reviewers who really just need to see the content. Triage is perfect for your issue and discussion managers who definitely shouldn't have write access. Write obviously goes to your active pushers. Maintain is a great fit for project managers who need to run the repository but shouldn't be accessing sensitive, destructive actions. And finally, admin. That is reserved strictly for full security and repository control. Keep that circle small. Which brings us to Section 3, automating releases and documentation. Okay, so now that our code base is scaling properly and we've got it locked down securely, it's time to speed up the delivery phase. We really want to let automation do the heavy lifting here. A structured timeline relies entirely on semantic versioning and tags, which act as exact point-in-time snapshots of your project's history. For example, v1.0.0 marks your stable production baseline. But what if a feature is still in the testing phase? Well, you'd use a pre-release tag, something like v1.1.0-alpha. So collaborators instantly know, hey, this is not ready for production. And for big, significant additions, you use descriptive tags like feature/new login page. Doing this prevents a messy, confusing history and gives everyone on the team a crystal clear map of your development milestones. But look, nobody wants to sit there and manually decipher raw Git logs just to figure out what actually changed in those versions. In fact, dumping raw logs into a changelog creates a highly technical, confusing mess. Instead, just automate it. Step 1, create a release.yaml file right in your .github directory. Step 2, write out your exclusion rules in YAML format. This lets you filter out things like minor pull request labels or even specific authors. Step 3, commit that file. And step 4, simply hit auto-generate release notes. That's it. The system handles the rest and perfectly categorizes your team's hard work for you. And hey, that automation shouldn't just stop at release notes. It absolutely has to include your API documentation too. The crucial move here is integrating these tools directly into your CI/CD pipeline. You can use OpenAPI or Swagger to auto-generate API specs directly from the code itself. From there, static site generators like Jekyll or MDocs can easily convert that into clean, readable Markdown. Finally, use GitHub Actions to automatically build and deploy these HTML pages to GitHub pages every single time the code changes. Set this up and your developers will literally never be stuck looking at outdated API instructions again. It's a lifesaver. And finally, Section 4, Data Cleanup and Recovery. So we've reached the most dramatic part of the repository lifecycle. When things go wrong in enterprise DevOps, they go really wrong. Picture this. It is 4:59 p.m. on a Friday, and a developer accidentally commits a file containing live API keys and plain text passwords straight into the repository. It is every developer's absolute worst nightmare. Because Git is specifically designed to efficiently store long histories, that sensitive data doesn't just go away if you simply delete the file in a new commit. Oh no, it is buried deep within the repository's permanent history, just waiting to be exploited. But take a breath. You don't have to delete the whole repository and start over. You can use open source history rewriting tools. Now, while Git Filter Repo is highly customizable, BFG Repo Cleaner is usually the go-to tool for this specific crisis because it is incredibly fast and just much easier to use under pressure. By running BFG-replace text, you literally command it to comb through the entire history of your massive repository, find every single instance of that leaked password, and permanently mask or scrub it from existence. Codebase secured, disaster averted. Now, let's pivot to another really high-stakes scenario. What if, instead of adding something you shouldn't have, essential work just completely vanishes? Say someone accidentally deleted a crucial file, or they completely lost a commit they just spent 3 days working on. The panic sets in pretty fast, right? Well, here's the secret. Git rarely forgets. If you need to resurrect a deleted file, first you track down the commit's SHA-1 hash. You can do this using git log or git reflog. Or if a commit seems totally orphaned, running git fsck, lost found, will usually track it down. Once you have that hash, you use a targeted git checkout command. The real magic trick here is appending that little caret symbol right after the hash. That tells Git to look at the parent of that commit. So you're effectively rewinding time to the exact moment right before the file was deleted, allowing you to seamlessly pull it back from the dead. So the entire goal of enterprise DevOps really comes down to control and efficiency at scale. We've seen how to choose the right architecture, how to implement specialized tools like Scalar for massive files, lock down your permissions, automate the busy work, and most importantly, recover from those terrifying worst-case scenarios. So I'll leave you with this provocative thought as you evaluate your own setup. Are your repositories working for your team? Or is your team working for your repositories? Take these playbook strategies, reclaim your time, and make your infrastructure actually work for you. Thanks for joining me on this explainer.